So this is the way of writing a set builder form. Now suppose if this would not be a set builder form, this would be suppose roster method, listing method. Then can you tell me all the natural numbers between, okay, only between 1 and 10?
Okay.
What are they?
2, 3, 4, 5, 6, 7, 8, and 9.
So this set A, in the listing method, it will look like this. And in the set builder method, it will look like this. Is this clear? We'll do more examples so you will have a good understanding of it. Okay, so I'll just read this again for you. Set A is set of all x such that x belongs to natural number and x is between 1 and 10. Okay, so let's move on now. Okay, before moving on, again, I will want you to revise these points. So you do not write the list of elements, but you write the general element using variables followed by a vertical line. Vertical line is usually read as such that, and a colon, vertical line or a colon. Okay, you can put a vertical line or you can put a colon. Okay, don't put both. Okay, don't put both. That is wrong. Either one of the things. And then you write the property of that variable. So in this case, the property of the variable x was that x is a number between 1 and 10. That was a property. So it totally depends on the question, what the property of that variable is. Fine?
Yes, sir.
Okay, look at this. How will you read this?
The set B is such that
set of x
is such that x is a prime number between 1 and 10.
Okay. Yeah, the answer is already written, but we'll still do it. So x such that x is a prime number between 1 and 10. So if you list all of this, if you list all of the x, so what are all the prime numbers between 1 and 10?
2, 3, 5, 7.
So here, what is the property of x? What is the property of x here?
2, 3, 5, 7.
Property. In the previous one, if you see the no. In the previous example, in this example, if you see, the property of x was that x is a natural number between 1 and 10. That was the property of the variable x. So here, what the property of x will be?
Is that x is a prime number between 1 and 10.
Correct. Whenever I say property of the variable, that means whatever the question, whatever x represents, correct. So few points to note in this. Usually equal to is read as is. So B is a set that we will say. Curly bracket set of, okay, in set builder form. Line represents such that. This sign we already studied. This is called belongs to. Okay, here line or colon, such that. One and the same they mean. Line, this single vertical line, or this colon means such that. And comma is usually read as and. Okay, so this is a notation. This is the way you read. So when it is equal to, you say is. When the curly bracket starts, you say set of. For the vertical line, you say such that. This sign, obviously, you know, belongs to. And whenever there is a comma, you say and. This we did. Now let's do the exercise. Question 2. This third one was remaining. First two we did, yes, in our Tuesday's class. Third one was remaining. Okay. Now third one is given in which form? Is it listing or is it set builder?
Set builder form.
Set builder form. Can you read it for me?
A set P is such that P is an odd number.
Correct. Now convert this into correct. You said correct. Set P is such that its set of P is an odd number. Okay, we had to just write in the symbolic word statement.
Yes.
So, can you write it down this? Because this is from the exercise.
Done, sir.
Okay. Can you just put your book in front of the camera and show me how you're writing?
Yes. Sorry, sir. Because of my handwriting, sir.
Yes, you have to work on your handwriting.
Yes, sir.
Just catch the book straight. Okay, you have not put the question numbers. Okay, put the numbers.
Yes.
Numbers. Otherwise, later on, then you could get confused. Practice set, write the heading also properly. Just practice set 1.1, question number 2, the third one you're doing. Write all these things.
Done, sir.
Okay. Okay, now we'll do the next part of your exercise. That is the question number 5, and that says, write the following sets using rule method, okay, or the set builder form. You have to write, this question is given in the listing method, and you have to write this in the set builder form. Okay. Now, look at these numbers. What can you see in these numbers?
I see numbers from 1 to 100, but I don't understand the pattern.
Yeah, try. Give it a think about it. Try thinking. You can take your time. Can you tell me what is the square of 1? Square.
It would be 1.
Square of 2?
4.
Square of 3?
Oh. 9.
Square of 4?
16.
16. Now you can think what it is. Square of 5?
Yes.
25
25.
and so on. Now this has to be first, you have to introduce a variable.
Yes.
You have to now introduce a variable. And which is the last number? Is the square of which number?
10.
10. So that means this set
From number 1 to 10,
yes,
we have to find the squares.
You don't have to find, it's already given. So you have, now pay attention carefully. So you set A is equal to, it's a set of all such variable x such that x equal to, it is a square of that number. So x is equal to n square. Yes. But what is the condition on n? Which is the smallest and highest number? It is between what?
1 to 10.
1 to 10. Or you can say that n is a natural number, because we know natural number starts from 1.
1.
So n is a natural number, but n is not, which is the maximum? 10.
10.
So n is lesser than equal to 10. Lesser than or equal to 10. I hope you know this sign, lesser than equal to.
Yes, sir, I learned it.
Okay. So lesser than equal to 10 means the value of n is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Can it be 11?
No, sir.
No, it cannot be 11. So this is the way you write your set. Okay, pay attention once again. I'll repeat. A is a set of all x such that x is equal to n square. N is a natural number. Why we are taking natural number? Because it starts from 1.
1.
And the condition on that is n is lesser than or equal to 10. Clear?
Yes, sir.
Now understand and write.
Myself.
Yes, understand properly and write. Each and every line that you're writing, you need to understand it. If you're not understanding, just ask me again.
Yes, sir.
Done?
I have to write this in word form, right?
No, no, you have to write it in this form.
Yeah, I did so.
Can you just lift your book to the camera and show me how you have written?
Yes, sir.
Take it a little bit far from the camera. It's just blur. Yeah. Fine. Okay. I hope you have understood this.
Yes, sir.
Second one. Look at the second one. B. This is in the listing form. You have to write it in the set builder form. Look at the numbers carefully and tell me what
Table
can
of
you
6.
see. Yes, careful. Correct. Table of 6. Now, how will you write it? Just try to identify the pattern. First, x is equal to 6. And in the table of 6, where 6 comes? Where 6 comes?
Sorry,
Six.
sir.
In the table of 6, when does 6 comes?
First.
So how that is 6 into 1,
6,
correct?
1.
6
Yeah.
into 1. 12. What is 12?
2. 6 into 12.
6 into
12. 2. 6 into 2.
then third is 18. 18 is
6 into 3. 6 into 3.
Next is 24. So 24 is
6 into 4.
6 into 4. So what can you see in this pattern? X is 6 into 1, then x is 6 into 2, then 6 into 3, then 6 into... What is same and what is changing?
The table is same, but by the time it's multiplying, it's different.
6 is same. 6 is same, but this is changing.
Yes.
But how it is changing, can you see that? 1, 2, 3, 4.
It upgrades slowly, one number next.
Yeah. But what is 1, 2, 3, 4 and all? This is what? Set of
Natural numbers.
Natural numbers, correct. Natural numbers. So you can write this as B is equal to having all variable x such that x is equal to 6 into what is changing? 1, 2, 3, 4 is changing. So you can write it 6 into n. Correct? Because this n is changing. N is changing. Are you understanding this? But
yes, sir.
What is the last number in this?
48.
48. So 48 comes
8. 6 8, sir.
6 8s are. So what should the last value of n be? The first value of n is 1. Second value is 2, 3, 4 and all. So what's the last value?
8.
8. So there has to be some condition on n. What that condition should be?
N equals lesser than or equal to.
What?
Than 8.
8.
8.
Correct. Correct. Have you understood this?
Yes, sir.
Write it down. One more thing I forgot. You write here n is natural number.
N is natural. Okay.
Just look here one second. N is natural number. This can be written like this also.
Okay, sir.
So this can be written in a more compact way. X such that x equal to 6 into n. N is natural number. N belongs to natural or just n. Okay, just ignore that. And n is lesser than equal to 8. Clear now?
Yes, sir.
Write it down.
Yes, sir. Done.
Yeah. Look at the third. C is equal to, the set C is SMILE. This, how will you write it in the set builder form? The set C has what is this inside the set?
Letters.
Letters, correct, letters. So this is a very simple way of writing it. You can give it any variable name. So set C is having Y, but what are Y? What are these elements? You just now said them. What are they?
Letters.
And but what is a word? Letter of which word?
Smile.
Smile. So you write here Y. C is a set of Y such that Y is the letters of the word smile. Okay, this was easy.
Yes, sir.
Okay, right.
I just got confused because yeah. So, but this is a roster method, right?
Yeah.
But shouldn't be small letters. Sir?
Yes, it has to be in small letters. Yeah, it has to be in small letters. S, N, I, L, and E. This has to be in small letters. Done?
Yes, sir.
The word, it can be miles or it can be
Miles or
lines also. Okay, but anything, you can write any one. Okay, this will be easier for you. How will you write this in the roster method, set builder method? What are these? What are these?
Days of the week.
Days of the week. Yeah. So how will you write it? Just tell me orally. First, be the set name D.
D curly bracket X such that
when you're writing set builder form, what does curly bracket means?
set of.
Nothing.
D is set of X such that X is the days of the week.
Correct. Perfect. Write it down.
Done, sir.
Look at the next one. What can you see in this?
X equals AET.
That builder form, how will you say? It's the same like the smiles example, same like that.
Yes, sir. X is the set of
Use some new variable. This is already X.
X is the set of C such that C is the letter of the word T.
The word T.
T.
T. Okay. Correct. T, then it can be eat also. Any word it can.
Yes, sir. Or eat. Letter in the word. Done, sir.
So we have finished this first exercise, practice at 1.1, entire exercise. Your homework will be writing this entire exercise 1.1, practicing it again.
Yes, sir.
The next thing is types of sets. You need to understand what are the types of sets.
Sir, you're mute.
There are 5 types of sets. The first is called Singleton set. Second is the empty set or null set. Finite set, infinite set, and equal sets. So one by one, we'll see what is the definition, what does these sets mean, and we'll see examples also. So singleton set. So as the name such says, singleton. So what does single means?
One.
Just one.
Alone.
Alone. So a set consisting of single element, means just one element, is called as a singleton set. Okay, so if this is set A, this is just a picture notation of a set. So a set is usually denoted by a circle. If you visualize it, okay, if this is set A, and then if it has only one element into it, okay, or like this we can write A is equal to just one element 2, and we know what is this set. It is a set of even prime number. Okay, singleton set is clear.
Yes, sir.
Next is the empty set or null set. What does this mean, empty set? What should be inside the set?
There will be no elements here.
No elements in the set. Correct. No elements in the set. So if there is no elements in the set which satisfies the given condition, then this is called as a null set or empty set. Okay, you call it as a null set or empty set. So suppose if A is an empty set, then that is written like this, curly brackets and nothing inside.
Yes.
Or the second way of showing is that A is empty. So this sign is for empty.
Yes, sir.
This, you write this or this, but you don't write it like this. Okay? This is wrong way of writing empty set. You don't write it like this.
Yes, sir.
Either just brackets and nothing inside, or this, but not like this. Okay, both you cannot. You should not use both. You show empty set.
Yes, sir.
Here empty set.
Yes, sir.
So P is a natural number. Set P is a natural number between 2 and 3. So how will set B look like? What element will be?
B equal to such that.
No. Tell me in listing method. Natural number between 2 and 3. Now think a little bit about it. Between 2 and 3, is there a natural number?
No, sir.
Then we
type. Huh? Then we type that null.
Null. So this is empty.
Empty.
So this is empty. Third type is finite. What does finite mean? Limited, correct. Limited. That means it will get over at some time. It will finish at some time. So if it is a null set or number of elements are limited and countable. Okay, countable means it is possible for you to count. Then it is called as a finite set. Okay, so the set is limited and it is countable. That means you can count it. So let's say, for example, set B such that P is an even number between 1 to 10. So what will be all in B?
2, 4, 6, 8, and 10.
Okay, I'm saying between 1 and 10. Between.
Okay, so wait.
Only between. So this had only limited elements into it. So this is a finite set. Okay. Next. Okay, this was an example of finite set. Can you read this?
C is a set of variable P such that P is a number from 1 to 22 divisible by 4.
Divisible by 4. So now first of all, can you tell me this in how to write it in the roster form? What are all the numbers between 1 and 22 that is divisible by 4?
First 4 itself, 8, 12, 16, and 20.
20. Any more?
No, sir.
This is an example of finite set. Now, empty set is also called as a finite set. Okay. So suppose if A is empty, then this will be also called as finite. Set A is finite. Okay. Is this point clear? What does this mean?
Yes. Yes.
So an empty set is also a finite set. Now, this is opposite of finite, that is infinite set. What will this mean?
It will never end.
Yes, it will never end. So if numbers of an element
name all
is,
the prime numbers.
Yeah, if numbers of an element is unlimited and uncountable, that means not possible to count, then this set is called as an infinite set. So see, set of natural numbers. 1, 2, 3, 4, dot, dot, never ending, not possible to count. So this is an example of infinite set. Can you give me one example of infinite set?
Even numbers.
Set of even numbers, correct. Set of even numbers is an infinite set. Okay, can you read this example for me?
Which one, sir?
This one.
Okay. A is such that X is such that
set of. Curly bracket is read as set of.
A set of X is set of the variable X such that X belongs to the natural number and X is an odd number.
X is an odd number. Now, will this set be finite or infinite? X is an odd number.
Infinite.
Set of odd. Yes.
Infinite.
So if I write this in the roster form, so it will look like this. No odd number. 1, 3, 5, 7, dot, 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 never ending. So this is infinite set. Last is equal sets. What does equal mean? Can you hear me? Can you hear me, Chris?
Yes, sir.
Okay, I think it got disconnected. Okay. Last was equal sets.
Yes.
So two sets A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. Okay, so set A and set B are equal sets. So symbolically, you write it like this: A is equal to B. The simple meaning of this definition is elements in set A and elements in set B should be same. They should be same. Let's say, for example, set A has 1, 2, and 3, and set B is 1 and 2. Can I say A is equal to B?
No, sir.
No, you cannot, because one element is missing. So if, and look at C. C is 1, 2. Can you say B equal to C?
Yes, sir.
Yes. Why? Because elements in B and elements in C are exactly the same. So that is why they are said to be as equal sets. Okay. Can you read this?
A is a set of X variable. X is a X variable such that X is a letter of the word listen.
So this in the roster form, listing form, it will look like this, correct?
Yes, sir.
LISTEN. Now B, can you read this?
B is a set of the variable Y such that Y is the letter of the word silent.
In roster form, how will this look like?
SILEN.
Now look at set A and look at set B. What can you see?
The elements are matching.
Elements are matching. So can you say A is equal to B?
Yes, sir.
So the order does not matter. So your L is first, your S is first. That is not important. But all the elements are the same. So S is same, I is same, L is same, E also, N, and lastly T. All are same. All the elements, each and every element are same. So you can say set A and B are equal.
Yes, sir.
So the elements of set A and B are not in the same order, but all elements are identical. Okay, identical means same.
Same.
So A is equal to B.
B.
Okay, look at set A and set B. Are they equal or not equal?
They are equal.
They are equal. Look at the second example of set A and set B. So they are figures. So first, what is this first figure?
Square.
This.
Triangle.
And this?
Pentagon.
Pentagon. Are both of these sets same?
Yes, sir.
They are the same figure, yes. So they are equal. Okay. We just do from the practice set 1.2, we'll just do one sum and we'll stop. So this says decide which of the following sets are equal and why, and justify your answer. Can you read this?
Okay, sir. A is a set of the variable x such that 3x minus 1 is 2.
Equal to 2. Here you can say equal to. Only this first we say it as is, but this is an equation. So you say equal to 2. Okay. Now this is in the set builder form. In roster form, how will this become? X such that this equation. So it is 3x minus 1 equal to 2. You have to solve this to find the value of x. How will you do it? You take minus 1 on the other side of the equal to sign. What will happen?
Plus.
This becomes 3x is equal to 2 plus 1. Correct? So this becomes 3x is equal to 3. So what will be x equal to?
X equal to 3.
X is equal to 3. So x is equal to?
X is equal to 3.
1. Now, okay, you look here. I need to find the value of x. But here with x, what is the coefficient of x?
3.
3. So you need to get rid of this 3. You need to remove this 3. What can be done to remove this 3?
We put x aside and we divide.
Yeah, divide by 3. Divide. So you will write here divide both sides by 3. Okay, because there's an equal to sign. So both the side you have to do the same thing. So divide both sides by 3. So this becomes 3x upon 3 equal to 3 upon 3. So both the sides are divided by 3. Correct?
Yes.
So here 3 and 3 cancel. So you have x. And here also 3 and 3 cancel. So what remains? 3 divided by 3 is 1.
1.
So what is the value of x?
X equals 1.
X equal to 1. So that means this set has what element in it?
X.
But what is x?
1. 1.
1. So isn't this what type of set?
Singleton set.
Okay, we have still not finished with the sum. I want you to write this up to here and we'll continue tomorrow.
Done, sir.
Done? Okay.
Yes, sir.
So we'll stop here, and this sum will continue in the next class. Can you show me the book? Let me see how you have written. Oh, perfect. Good. Okay, so we'll continue tomorrow.
Okay, sir.
Tomorrow, same timing, 5 o'clock. And one
5
more
o'clock.
thing. So now every week, can we keep these days permanent? Tuesday, Thursday, Friday,
Okay.
permanent.
Yes, sir.
Is your mom around? Can I talk to her?
Sir.
Yes, sir.
Yes, ma'am. Ma'am, I wanted to ask one thing. I'll take a class tomorrow, and now every week, can I keep these days permanent? Tuesday, Thursday, Friday.
Yeah, it's fine.
It's,
Yes, sir. Yes,
it's fine, right?
yes, sir.
Okay. So
That's
every week these days will be permanent. Tuesday, Thursday, Friday, 5 o'clock. Okay.
Okay, sir. Yes,
So
sir.
see you tomorrow then, please. By the way, don't forget the homework. What was the homework?
Okay.
Bye, sir.
Thanks. Bye, sir. Yeah.